This is video lecture number 4 for chapter 19, which is simply going over the review sheet on the second last page of the handouts packet. So the first part wants us to fill in oxidation numbers. A free element by itself, 0, 0, 0. If we have a compound, it has to total charges add up to 0. Sodium is +1, it's group 1. The top number for chlorine is -1. Beryllium has to be +2 because chlorine is -1 and there's 2 of them. Water, +1, -2. Here is one of our exceptions, a peroxide. H is +1, so O is -1. Here is another exception. Oxygen is +2 because fluorine has to be -1. So sodium peroxide, here is our exception. Sodium is +1, oxygen is -1. Here is an exception for hydrogen. If it's with group 1, lithium will be +1, so hydrogen is -1. Calcium of group 2 is +2, so hydrogen is -1. If we have multiple positive charges, assign the negative ion first, which means iron has to be +2. If chlorine is -1, but there's 3 of them, iron has to be +3. If we have an ion, we have to add up to the charge of the ion. Oxygen is -2, but there's 3 of them, so carbon has to be +4. MnO4-, oxygen is -2, there's 4 of them, so Mn has to be +7. SO3-2, oxygen is -2, there's 3 of them, so sulfur has to be +4. If we have more than 2 elements, save the one in the middle for last. H is +1, O is -2, so sulfur has to be +6. Oxidation is an increase in oxidation number. It is a loss of electrons, so we think of oil. Reduction is a decrease in oxidation number. It is a gain of electrons. We think of Rig. Metals, since they form positive ions, will lose electrons to form positive ions. Therefore, they are easily oxidized because the charge goes up, or are good. Remember the opposite. If you are oxidized, you are a reducing agent. Nonmetals will gain electrons to form negative ions. Therefore, they are easily reduced because their charge goes down, or we say they are good oxidizing agents. If we fill in the oxidation numbers, sodium, free element, is 0. Chlorine, free element, 0. Sodium is +1. Chlorine is -1. What's oxidized? Na0 goes up to +1. Since it's oxidized, it loses electrons. Cl0 is reduced. It gains electrons. The oxidizing agent is the opposite thing. So since Cl0 was reduced, it is the oxidizing agent. Remember though, if you're reduced, you gain electrons. The reducing agent is the thing that was oxidized. It is Na0, and it loses electrons. For this equation, we balance, or we write in our charges 0, -1 for chlorine, so +2, 0, -1 for chlorine, so +3. The oxidation half reaction, aluminum goes from 0 to +3. Remember, charge went up, so the electrons are to the right, upright. Cu2+ is reduced. It gains 2 electrons to form Cu0. To write a net ionic equation, we have to balance electrons. So we multiply this equation by 2, this equation by 3. So we can write out 2Al0 plus 3Cu2 plus arrow 2Al3 plus 3Cu0. Since chlorine is a -1 and it ends up a -1, chlorine is considered to be a spectator ion. To balance a complex redox reaction, step 1, we assign charges. We pull out the oxidation half reaction and the reduction half reaction. S goes from, oops, I messed up here. H is +1, so S is -2. Sulfur goes from -2 to 0. Oxidized, loses 2 electrons. Nitrogen is reduced, N+5, gains 3 electrons to turn into N+2. We balance the half reactions so that there is a conservation of electrons. So the top one is multiplied by 3 and the bottom one by 2. Wherever there's an S, we'll put a 3. Wherever there's an N, we'll put a 2. And then we still have to balance hydrogens. 6 plus 2 is 8. So we put a 4 in front, and then we can balance oxygens. To balance net ionic equations, we simply connect the two things that are similar and see how many electrons they change by. And then we multiply so that they equal out. So this one, we multiply by 2. So wherever coppers are, the copper plus and the copper atom, we put a 2 in front. Aluminum changes by 3 electrons. Magnesium changes by 2 electrons. So we multiply this one by 3, this one by 2. So where magnesium is, we put a 3, and where aluminum is, we put a 2. The last concept is table J for reactivity. We only use this for a single replacement reaction. The atom that is higher up replaces the atom in a compound. So will the following reactions happen? In other words, if we look on table J, is zinc above the copper of copper chloride? Yes, it is. Make sure you check table J. Is aluminum above magnesium? Sorry, is magnesium above the aluminum chloride solution? Yes, it is. Don't worry about the third one right now. And then the fourth one is copper above a solution of calcium chloride? And no, it is not. If the reaction happens, let's go ahead and balance. Zn, Zn, 2 chlorines, 2 chlorines, copper, copper. So these all have a coefficient of 1. Here I can kind of see the problem. 3 chlorines, 2 chlorines. So a number common to both is 6. So I double this one and triple this one, which gives me 3 magnesiums and 2 aluminums. So that takes care of the review sheet for Chapter 19. Have a great weekend, and we will see you on Monday.